Hi there. Well, you said good morning, but for me it's afternoon already. Hi everyone. Good day. This webinar will be about the basics of Git version control system, specifically meant for people that already have some experience with Subversion. However, because it's mostly the basics, even if you don't have any experience with Subversion, I think you should be fine. If there's any stuff that you really don't understand, just leave a remark in the chat, and perhaps Kevin can interrupt me if I'm really unclear. So let's just get started. I have a couple of slides to explain to you the concepts, to compare the basic Git commands to the basic Subversion commands. And then I'm going to try and give you a short demo of how to work with Git. Okay, so first, for people who don't know me, my name is Stefan Koopmanstrap. I am a freelancer. I run my own business called Ingewikkeld, which, if you translate it to English, means complex, which is the projects that I like. I am also the community manager of Symfony Framework. Basically, I help people help the framework. And I'm part of the event crew of PSZ.nl, which is a web development user group. We organize events, amongst which PF Congress, which will be in September again. Enough about me. Let's start off with a small disclaimer. I am used to the command line when using Git, and I think it is important to know about the actual commands that you have to use when working with Git. There are graphical interfaces. There are a lot of graphical interfaces, but sometimes they use a different terminology from the actual Git terminology. For instance, because they started out as Subversion applications, and they basically just changed the underlying version control system, but they still use the same terminology. So today I will only be using the command line. I will only be showing you command line stuff. But of course, feel free to start using some kind of graphical interface for Git as soon as you start working with Git. I know at least for Mac and for Linux there are a couple of good ones out there. I have no idea about Microsoft Windows. So let's start with the basic concepts. If you're used to Subversion, this is basically how you work with Subversion. You have a server. On that server you have a repository, and each developer has their own individual checkout of the repository, which is their local working copy. They change stuff in the working copy, and as soon as they commit it, it gets sent back to the server. Obviously, this works well because we've been working with it for years and years and years with this concept, not just with Subversion, but also with the systems before that. However, it can be done differently, and that's basically how Git works. Git works like this, and you're going to see a lot of arrows here going back and forth and back and forth. Yes, it can get as messy as this, but of course, if you do it well, it won't be as messy as this. But this does show you the basic idea of Git, where you don't have a single repository on a single server, but every single developer has their own repository on their own computer. And then they have a local checkout, which is their working copy, where they can change stuff. And as soon as they commit stuff, then it goes into their local repository, and no one else will still have that unless they share it. And all these checkouts can be linked to other checkouts or other repositories. So you can end up with your local checkout and then having 2 or 3 or 4 different repository servers linked to it, where you can get data from or push data to. But don't worry if you don't understand it right now. We're going to get into that a bit later. So you want to start out. When you start working with Subversion and you need a new repository, you need to create that using SVN admin create, or in most cases you need to ask your system administrator to create a Subversion repository for you on the server. With Git, it's a bit more simple. If it works, yes, there we go. You just use git init. And what git init does is actually it creates a repository in the current directory that you're working in. So you don't need to do this on a server, you do this on your local machine. And what it does is it creates an empty repository and you can start adding stuff to that. Of course, this repository is only accessible to you unless you give remote access to your local workstation. So you, at that point, you're not sharing anything yet. Now, once you've created this repository with Subversion and you've done the checkout, then you can add files using svn add. Well, that's very simple, basic stuff, of course. With Git, it's the same thing. You can use git add to add files to the repository. However, git add has a double meaning. Git add is not just used for adding files that are not under version control yet, but you also use git add to add files to what is called the staging. Staging in Git is basically a list of files that you want to commit at a later point, but you are not committing it yet. So when you have when you change the file and you do git commit like you would do with svn commit, then git commit won't do anything because it won't know what to commit unless you say, okay, git add whatever the changed file, and then you can commit. In the demo, it probably will get a bit clearer because then I will actually show you what happens. Wait, I'm going back now. Right, there we go. So then, basically, I already talked about commits. So in Subversion, what happens when you commit is all the changed files or the files that you specify get committed to the repository. This means that as soon as you do svn commit, it actually sends your changes to the server, and any other team members working with the same repository will be able to get your changes. Now with Git, even though the command is the same, git commit, it doesn't actually send it to a server yet. It commits it to your local repository that is on your local machine. This has some advantages and some disadvantages, of course. The main thing is, of course, that you don't need an internet connection to keep version control on your project, because as soon as you're done with the task, you can actually commit those changes to the repository and then keep on working. So when you're in a train or on a plane or whatever, you don't have access to the internet, you can actually commit stuff. And that's one of the problems that you have when you use Subversion. If you're working somewhere where you don't have an internet connection, by the time you get back to the internet connection, you have to commit everything all at once. And obviously it's a best practice to commit only small changes at a time, only those changes that are related to each other, so that at some point, if you need to revert it, you can just revert a single commit and you're done. Talking about reverting, svn revert, yeah, that's just reverting a change back to an older version, or a file back to an older version. You can do the same thing with Git, where you can say git checkout --, you go back one revision, or you could specify a commit hash, and then it will go back to that one. And then there's one concept that Subversion doesn't have yet. As I explained before, when you want to commit a file, you have to add it first to the staging. Now there is a point where you add something to staging and then you remember, oh wait, I forgot something and I need to do that as well. So then you can say, okay, we do a reset head file. That basically means you take the file from staging and put it back into your working copy. So when you then do commit, it will not actually commit that file. It's unstaging a file basically. And obviously the simple ones, status, SVN status, and git status are the same. The advantage of git status, in my opinion, is that git status gives you a lot of information on what you can actually do. It will tell you how to stage a file, how to commit a file, how to add a file, stuff like that. I will show you in the demo later on. So now that's the real basics. At some point you will want to start sharing your code with the rest of your team, or maybe even the rest of the world. So yeah, how do we do that? Because with Subversion, once you commit, it goes to the server, and then everyone has it already. But with Git, once you commit, it's still only on your local machine. So Subversion says, Git says, okay, that's okay. You commit locally, and then you can work with remotes, or you could take a remote repository and clone that to your local system, and then start working with that, and it will automatically create the remote. You could make a clone locally and then share that clone. Obviously, basically what the clone does is it creates an exact copy of your repository, and you can just pass around that copy of the repository. Obviously, you can just zip the whole directory, your whole project directory, and then share that via email or whatever. But this is all not really practical. So that's why you have Git remote. Basically, what Git remote does is it tells your local repository that there is a repository somewhere else that is related to this repository. So you can have a server somewhere with the Git repository there, and you set up the remote on your local repository, and then you can start sending information back and forth. So you can actually get stuff from the server or send stuff there, which is related, I guess, to Subversion commit or SVN update. So to get changes from other people that other people put into the repository, the remote repository, you can say git pull. So git pull actually does two things. It will fetch the changes from the remote repository, and then it will merge those changes into your local working copy. You could do it with two separate steps, like git to actually merge the data. But in most cases, git pull will be easier for you because you will probably just need all the changes of your team member. As I mentioned, you can do the fetching and the merging manually. This is especially interesting if you're a QA person or team lead or something like that, where you want to fetch the changes but not automatically merge them with your local checkout, but you want to get only specific commits out of the commits that were in the central repository. So now, once you have some changes, you've done some changes, and you want to share that with other people, you can use git push. And git push will actually send your local changes to the server, to the specified remote, so that other people can get it from there using git pull. Now there's a couple of services out there that will help you with this. Obviously you can set up your own server and have your Git repositories hosted there. But GitHub is probably, especially for open source, my favorite Git hosting service. There is a couple of others though. Bitbucket also does Git hosting, and the traditional Subversion hosting systems like Unfuddle do also do Git hosting, which can be useful if you already use them for Subversion hosting as well. Now, one of the most interesting features of Git is the branching system. Obviously, Subversion had a branching system as well, but the problem is when you create a branch, you create a branch on the server. So that means that this creates a bit of overhead in the communication and stuff like that, making it more expensive, because every time I need to do something with the branch, work with that branch, I need to basically communicate with the server, which can be annoying. Branching in Git works a bit differently, because it's all local, because your repository is local as well. So it's very cheap. You just create a branch and that's it. It's one command, and you created a local branch, and you can work in that branch, and then once you're done, you can merge changes back. Switching is very easy. You just type a single command and it will switch over. And so it's very easy to work with different branches and keep track of different branches. I'm going to mention the tagging as well. Tagging obviously is also similar as you did with Subversion, with the difference that in Subversion you could actually commit to a tag, because a tag was nothing more than basically a copy of the repository. Tagging in Git is basically a snapshot. So you create a tag based on whatever code is in your repository at that point, and then that's it. You won't be able to change it anymore. If you want something changed, you have to create a new tag, which is actually better, because the idea of tagging is to create a snapshot, which you can use, for instance, for saying, okay, this is version 2 of our code base, and now this is a stable version, and people can actually start linking against that in their own code base. Another feature that is really useful for Subversion is SVN externals, where you can actually link to another Subversion repository to import that code basically as soon as you check it out from the repository, without having to keep a copy of that code in your own repository. Git has a very similar thing, even though it's slightly different, and that's submodules. One of the main differences is that where if you use SVN externals and you make a checkout or you do a SVN update, it will automatically also contact the externals. With the submodule system, it won't do that. You have to specify that it has to update the submodules, because, well, if you do SVN up, it's simple, because there's only one server to connect and then the externals. But with Git, there is no Git update, because when you pull, you have to specify from which server you want to pull, so it doesn't know anything about whether it should update submodules or not. So you can just say, okay, so there's a submodule, specify the repository and the name, and then it will add the submodule to your repository. But then you have to run git submodule update to update the submodules, instead of just SVN up or something like that. And the first time after you set up a submodule, the first time after you set up a submodule, or the first time just as you cloned a new or created a new clone of an external repository, you have to say git submodule init, and this will initialize basically your local submodule setup. So it will, submodules will be saved in the repository and will be saved when you make a new clone, but before it will actually fetch the data, you have to do run git submodule init and then update to get the actual submodules. Another useful feature, obviously, is git blame, which is very similar to Subversion blame, in that it will be able to tell you who committed what at what point and for what in what commit. So this is very similar, actually, to SVN blame. Another really useful feature is git SVN. Git SVN is very useful if, for instance, the organization you work for has a Subversion server and they don't want to switch to Git, but you still want to use the power of Git on your local system. It allows you to configure Git to talk to a Subversion repository instead of a Git repository. And actually, where I work right now, they use Subversion. And I actually use git SVN to be able to use the Git branching system mostly, because I work with, on 3 different versions of the current code base, so it's very easy to switch branches with Git, and then if I do a bug fix on the current stable release, I can easily merge it to my development version. And it works very similar to Git. To Git remotes, in that I can say, okay, give me update from the Subversion repository, or push stuff back to the repository. The only difference is the syntax of the commands, because I have to use git svn rebase to get stuff from the server, and git svn decommit to actually send it to the server. And why is this different? Well, the concepts of Subversion are different from the concepts of Git. So Git has to make the translation to Subversion. But the great thing is, when you push your changes to a Subversion server, it will recognize all of the commits that you did in Git, and all those commits will be converted to Subversion commits. So it's not just one big commit that you do into Subversion, it will all be separate commits. And this can be really useful if the organization you work for doesn't want to switch to Git, but you want to use it. Another feature that I really like is git stash. Git stash basically allows you to set aside all of your local changes for a second and revert your code base to the last committed version. It's like a clipboard. You just copy all of your changes to a clipboard. Your local code base will be reverted to the last version that was actually committed, and you can actually make some changes, more changes to the code base, and then commit that. A useful situation where you can use this is when you're working on a new feature and you find out there's actually a bug in your existing code base. You can actually stash all of the new development, fix the bug, commit the bug, and then apply the stash back onto your code base. And this allows you to keep committing only small stuff. Whereas if you would change the bug while you were working on the new code base or new feature, and you would commit that, the commit would actually contain your new feature plus the bug fix, which would, well, really be annoying, because it's very hard then to find out what happened in your code base and why it happened. Another situation where I use git stash every once in a while is when I'm not completely sure of which solution I should use. If there's multiple ways to solve a certain problem, I can just implement one solution, stash that solution, then implement the second solution, and then compare which one is better, and then decide, okay, I need to keep the new solution and remove the stash, or I need to revert back to the committed code and then apply the stash again, because that one was actually a better solution. The stash can actually contain multiple different versions, so I can work out 4 different solutions and then decide on which one I actually want to apply, and then I can throw away the rest. So yeah, this is a really nice solution. Rebase, yeah, rebase is a very powerful feature, but also a very dangerous feature, because it will give you a lot of control over what happens basically in your history. You can rewrite history using that. Rebasing is just like merging, so you have different branches, and you basically merge the changes of those branches into one branch. It is a bit more powerful though, and also more dangerous. So let me try to explain that using a bit of, well, fancy graphics. So I start off at point 1, and then I have, so this is merging, what I'm describing right now. I create 2 different branches. For some reason I've called them origin and branch here. And in both branches some commits happen. And at some point I decide, okay, everything is fine now and I need to merge everything together so I can get a new release out the door. So I merge stuff, but now if I run into issues, then I get conflicts because of the merging, because things changed in the same lines or something like that. I actually will get a new commit for the merge. And yeah, that of course it doesn't have to be a problem, but yeah, it could be a problem that you get a new commit. But more importantly, you're basically forced to accept most of the changes. Now with rebasing, you start out in the same way, but instead of merging, you use rebase. See the fancy graphics? What happens when you do rebase is basically you set aside all of the changes of one branch, and then you put them after the other. And this allows you to say, okay, all of these commits are nice, but not all of them. Some of them need to be changed or deleted or whatever, which is basically rewriting history. So if you have conflicts, you can solve conflicts, obviously, and then say continue. But the most powerful part is the interactive part. What happens with the interactive part is that you run through each single commit in the rebasing, and for every commit you can say, okay, I want to keep this commit, I want to delete this commit, I want to edit this commit, or even I want to merge a couple of different commits. And I believe this merging of the commits is what Matthew Framework calls the Make Me Smart option. Because while you are developing, you commit stuff for a specific feature in 5 or 10 different commits, and then when you rebase, you merge it all into one commit, so it looks like you did all the work in a single commit, and that makes you really smart, of course. Yeah, you can specify for each commit what happens with that commit. This is very dangerous. You should only rebase on code that you haven't shared with the rest of your team yet. Why? Because if you delete the commit that someone else already pulled from the repository, then their history is fucked. So you really need to take care when using rebase, and typically rebasing is something that you either do on a feature branch locally, or when you are the project lead and we're trying to merge changes from one of your team members. Okay, so there's a lot of stuff. How does this work together? How do you use workflows in Git? So what I call the GitHub way, because I don't know if they invented this workflow, but they made it popular because of the way their website works, there is a central repository, and then every developer forks the repository. And forking in this case means they make a copy of the same repository also in GitHub, so also on the server. Then they clone to their local system so they can work locally, and they develop in a branch. So you make a clone of your own development repository. You start working on a feature, but you do that in a branch. You commit that in a branch, and then you push that branch back to your version on GitHub. So this means that when you push it to GitHub, it's still only in your version of the repository and not in the central repository. And then you send a pull request. And what a pull request is basically is you send an email to the person that's leading the team, asking them to merge your changes into the central repository so that all your team members will also be able to use your code. And then the lead developer for the project uses merge or erase and then pushes that to the central repository. And at that point, your change will be available for everyone to get. This is a really nice way. It adds some overhead. It adds a bit of process to the whole way you work. However, it also adds a nice place where you can do some quality assurance. Because your code will not automatically go into the central repository, but your lead developer will have the opportunity to check your code to see if there's any issues and reject the pull request if the code is not good enough. In the short run, this might lead to a bit more time, but in the long run, you actually have more quality control, so there will be less bugs in your code, at least if the lead developer does his job. Another workflow, when you use Git on your own, because I run my own company, I have a lot of projects that only I work on and no one else. You can create local branches in your local repository, and then whenever that's stable, you can merge it to the master branch, which master branch is similar to what trunk is in Subversion. And then you can push it to remote, and that's mostly for backup or because you deploy directly from Git. So in my case, I work on a project on my own system, and then I merged whatever I did in a branch, I merged that to the master. I push that master to the remote service, which could be a GitHub, for instance, and then on my server, I pull these changes into the server, and that's my deployment. This still makes it really easy to work with Git, and it allows you to do the branching thing and stashing and things like that. So as I mentioned, quality assurance is very easy with Git, because there is this point where a lead developer can actually look at the code that the other developers are pushing to their repository. So there is this point where you can actually do some checking of the code. Also, of course, most of the continuous integration systems have plugins for Git, so you can still automatically have your builds created and unit tests run to make sure that all of the changes are still, or the tests still pass with the changes that are being done. But because there is a bit more process, there is a stronger workflow system in Git, it allows you to do the quality assurance before the code gets to the other developers. One of the previous companies that I worked for, what happened there was by accident someone committed the deletion of a whole directory. And because they committed it to Subversion, the directory was deleted from the repository in the server, and if someone ran svn up, they would actually have their whole directory deleted. And obviously that is annoying, because people cannot work without, I don't know, a whole library. And with Git, they would push the deletion of the directory to their own repository that no one else checks, because people update from the central repository. So the team lead would be able to catch that problem before the rest of the team would be affected. One last thing before I go into the demo. You can actually make it a game, and this is actually quite fun, but also quite useful. There is a simple addition for Git that you install on your local system, which basically keeps track of every single command that you're doing in Git, and then you can actually get some achievements for doing stuff. Like this one, where some files were added to the index, for I don't know how many times, and that I gained level 3 of this achievement. So if you want to check that out, this is a short URL where you can get it. I will publish the slides later on, so you will be able to get the slides and check the link as well. Okay, so demo time. Let me switch to a terminal. So let me create a new directory of this awesome project that I'm doing. Awesome project. So this is an empty directory. I have to actually go into that. This is an empty directory. So if I want to create a new Git repository here, it's just git init. And as you see, it will tell you what it's doing. It created an empty Git repository. So here, in this Git repository, you don't really have to look at this, but this is your repository. This is where all your changes will be stored, all your history will be stored. So now let me just create a small file called index.php. Do the typical hello world example. So now if I do git status, and this is what I told you before, git status will give you a lot of information on what you can do with your file. Right now it tells me, okay, I have one untracked file, so that's not under version control yet, and you can use git add, and then the file, it will tell you that you can do that. So let me just add the file. So now I edit the file, but I haven't committed it yet, so I do status again, and it will tell me, okay, there are some changes to be committed. So now if I commit, I think WebEx is stealing my focus. If I commit something, and of course commit messages are really important, because if you do, there's a lot of people that say, okay, bug fix. This is not really useful because if you look through the history of your commits, or if your lead developer needs to look through your commits, he or she wants to know what happened in those files. So I'm just saying adding index.php. That's fine for me right now. So now it will tell me it actually changed one file and created a new file. So now if I look at git status, nothing changed. So I can create a branch. Let me call it webinar. And right now I'm still in master. You can see that here on branch master. And then to get to that branch, I say git checkout webinar. So now I switch to this branch called webinar. And when I open this file, let me just add a line break just as a demo. So now I change something, and it will tell me, okay, this is a modified file. You have to git add to update what will be committed. So that's basically to stage that file. Or I can do git checkout --, and then that file to revert the changes that I did. In this case, I want to add this. And now you can see that the changes to be committed is there again with this index.php file. So now if I commit and I say added line break, so now I committed it into this branch, and you can see here in which branch it was committed. So in this case, it's in the webinar branch. Important to note is that where Subversion uses revision numbers, which is a number that just gets added 1 every time you commit. With Git, you get a hash of that file, or of that commit, I must say. One of the reasons, because you don't have a central server, there is no way to prevent multiple commits with the same number, obviously, because I commit locally and it doesn't connect to a server, so it doesn't know what the next revision number will be. So you actually have to work with hashes like this. So I committed it into this branch. Now if I check out master again and look at the index.php file, you will see that the line break is not there. But obviously I can actually merge the webinar branch into my master branch, and now the index.php file contains the line break. So that's working locally with branching and merging, and this is quite easy. If I were in the webinar branch, I could actually create another branch based on that branch. So you can create a feature branch and then create a sub-feature branch based on the feature branch to work on a small part of the feature, and then go back to the feature branch and merge in that sub-feature. You can make it as complex as you want, really. But this will allow you to keep all your changes separated. And obviously, once you're done with a feature, you can remove the branch again. So now working with the remote, let me just, just because that's easiest, let me just create a new repository here. So now you can see here already that what stuff we can do. In this case, I need to add a remote. I already committed stuff. So what happens here is I tell Git that there is this server which is specified here, git at github.com, that I call origin. And origin, look at that, I achieved something. What this does is it creates an origin remote, and the origin remote basically is a name that is default to Git. When you create a clone from an external repository, it will always automatically create an origin remote, which is the server from which you cloned your repository. So now I called it origin, and now I can actually push changes. So I can say push to origin my master branch. And as soon as I push, I'm sharing that with other people. So now here on GitHub, you'll actually see that this file is here, and it will show you the last commit that I did, and it can actually show you the history as well. So the whole history of your file gets committed, not just the version that was committed last. So this allows anyone to, I see there's no sound for some people. This allows anyone to look at the history of the file and see what was committed for what. So now if let me just clone this into a different directory. So now I cloned this repository to a different directory, and basically that means that I get the whole history of this project into this new directory. So I could actually look at the log for index.php and see all of the commits that were done. So when you clone a repository, you don't just get the latest version of every file, you get the whole history. And that will allow you to make changes and share those changes again by pushing it. And of course, every once in a while you need to pull in the changes to other people. So that's basically that's basically the demo. Are there any questions?
Well, there was actually one question that I had before we get into some of the other ones. One of the things that I've often run into on Subversion is what happens when you try to commit conflicting pieces of code. You have to go through and you have to go, and you get those revision markers that you need to go through and make a bunch of changes to try and keep people from not breaking other people's code. Are there means for managing that in Git, or how would somebody go about managing those kinds of conflicts?
Well, you will still get conflicts if different people on the same team change the same line of code. You will get a conflict, and it will look about the same as it does in Subversion. The Git merging system is a bit smarter than the Subversion merging system, so it will recognize changes. It will not as easily get into conflicts as Subversion does. But yeah, you will get it. So what is usually done is when you pull in changes from other people, you usually pull it in to a separate branch, so it doesn't automatically cause trouble with your own changes, and then you solve the conflict and you merge it back into your into the feature branch that you're working in.
All right. Next question here. Well, there's a bunch of questions going on. We'll have no shortage of questions. One question: is there an equivalent for scripts that get executed on an SVN commit? So, like the various hooks that you can connect in. Is there an equivalent on Git for that? Yeah,
there's definitely hooks in Git as well. And actually, when you look at, let me just where's my focus? If I look into here, I actually see the hooks directory. So there are some samples there that you can use, but there's a lot of documentation about what you can actually do and when these will be triggered. But yes, you can hook into this on your local system as well as on the server.
All right. Next question here. In your team environment, where would you attach a continuous integration server? Does the team lead also become available for tracking down who broke the build?
Well, there's different places where you can hook it in. Obviously, every developer could have continuous integration on their own development version of the repository, which will allow stuff to be caught on that level. But most importantly, obviously, is to have continuous integration on your central repository, so that even if your team lead misses an issue, it will get caught as soon as he pushes it to the central repository. So I would put continuous integration at least onto the central repository, but it will allow you to have your developers have continuous integration on their own versions as well.
All right, next question here is, what about project management? With Subversion, you can, I'm paraphrasing here, with Subversion you can integrate with things like Python's track. Are there any similar open source team management tools that will hook in with Git or things like that?
I believe, but I'm not sure, that Track has a plugin for Git. And I know for sure that, for instance, Atlassian's Jira has a plugin for Git as well. I guess most project management and issue tracking software has some kind of plugin for Git.
Here's a kind of a basic question I think would be good. When do you specifically use pull and fetch and merge, and particularly the git remote function call, or the git remote calls? Can you provide any clarity in terms of workflow when you use pull, fetch, remote, that kind of stuff?
Right. If I work in a team where everyone uses Git, then at least once a day, usually in the morning when I get into the office, I do a pull to get in the last changes. The pushing is basically I push whenever I finish a feature. So the pushing is basically what you would usually do with committing in Subversion. With Subversion, when you're done with a feature. And with Git, you would push when you're done with the feature. And of course, if you're the team lead, then you pull in the changes whenever someone is finished with something, so you can merge it back into the central repository.
So it almost sounds in some ways like you do, a lot of individual commits on your local repository, but once you're done working on a specific feature, that's when you actually push to the remote repository?
Yes, that's correct.
Okay, cool. Let's see, we still have a couple minutes yet. So next question is here. After merging in Git with another developer, what happens when you're committing to SVN?
Can you repeat that question?
I think that this is talking about the Git SVN, the Git SVN integration. What happens in Git when you are working with another developer and they're committing to SVN and you're committing to Git?
Right. So all your commits to Git will still be local. You won't share anything unless you actually do a Git SVN decommit, which is let me just Git SVN decommit. So Git SVN decommit is like pushing to the Subversion repository. Now, if someone else committed while you were working locally, then you will get a message that you need to update first. So instead of before you actually do the decommit, you have to do Git SVN rebase to get the latest changes from the Subversion repository. And this is basically the same as when you were both working with Subversion. When you wanted to commit something to a file that someone else changed already, you would have to do Git SVN or SVN up first before you can actually commit. So it's basically the same workflow. So the workflow you would usually apply to Subversion would still be valid for the interaction between your Git and the Subversion repository, because Subversion works that way. However, locally, you could be using Git to create branches, to change stuff, and then when you're done, you can merge it and then decommit it, which basically commits it to the Subversion repository.
All right, next question here. Is it possible to have multiple SSH keys, for example, to have 2 different GitHub users on your system?
Yeah, that's that's more of an SSH question. I guess it's possible, but I don't know. I have never been in the situation where I needed that.
All right. Let's see. Next question. Oh, here's a good one. Is it possible to have several remotes? For example, a central repository and then another remote on your web server.
Yes. Actually, that is what remotes is about. Remotes allow you to have different servers where you can push stuff or pull changes from, and that's actually usually what especially the team lead will be doing. Is they will create a remote for every developer in their team, because they need to push or pull changes from those remotes to merge that into the central repository and then push it out to the central repository. So where I did git remote add origin and then the GitHub URL, I could say git remote add Kevin and then the URL to your repository. So I could actually pull the changes from there and then push it back to origin.
Is this related in any way to things like push and pull requests?
Sorry?
I've heard the term used, a pull request or a push request. Is that related in some way?
Yeah, the pull request, yes. So basically what happens, I can probably, so I don't have anything right now, but say, for instance, if I were to change something to Symfony, then I would do that in a branch, and then I could say pull request. And what happens then, of course, now there's not really any changes, but it would show here all the changes that I've done since the last version of the central Symfony repository. And then it would give me a text area where I can actually comment on the changes and tell people what I did. And this will help, in this case, Fabien, to decide on whether my pull request is good or not. So the whole thing about, and then once I click the button that sends the pull request, it will actually send an email to the maintainer of the central repository, telling them that there is a change that they might want to consider merging into their repository.
Now, is that something that's strictly related to GitHub, or is that something that's a Git feature?
Well, the term pull request is, I think, mostly a GitHub thing. But obviously, a pull request is basically an email that gets sent. So if you don't use GitHub, but you use your own server or another service, you could basically still do the same thing, but just send an email yourself instead of use the pull request feature.
One person here is looking for, actually, here, we're not going to be able to get to all the questions. There's actually a number we're not going to be able to get to. One here, is there a GUI for Git like Tortoise for SVN?
Yeah, so I think there is actually a Tortoise Git, which is Tortoise, but then using Git instead of SVN. There is, I think that's Tortoise is Windows. For Mac, there is stuff like Tower and Versions. And for Linux, I don't know the actual names of the Linux GUI clients, but there are GUI clients for most of the platforms.
Let's see if we can get a really quick question here. All right, we'll do one more here. When is it better to use stashing versus branching?
Well, you should use branching anyway. So the situation that I mentioned earlier, where you're working on a feature and then you run into a bug, what I would do there was I would stash my changes that I'm working on at that point, then create a new branch for the bug fix, fix the bug there, and then merge it back to my feature branch, or merge it back to whatever, or send a pull request for that. But that keeps the bug fix separated from the feature that I'm working on. So you always use branches for new features or new bug fixes, and then the stashing you use to just temporarily set aside the stuff that you've worked on when you need to do something else somewhere in between.
Cool. All right. Well, with that, we're going to have to shut it down here. I apologize to the people who have open questions in the Q&A. We just run out of time, but there's a lot of good questions there. I would definitely like to thank Stefan for taking the time to present to us here today. Again, this webinar is being recorded, and it's going to be up on the Zen.com website and shared via the Zen Facebook page and Twitter page. So with that, I would like to bid you a good day and hope to see you again soon at another Zen webinar in the near future. Talk to you later.
Okay, bye.